If you want to figure out what's really going wrong with the global economy right now, you probably shouldn't be looking at a stock ticker.
No, absolutely not.
Right. I mean, you should be looking at a massive cargo ship intentionally turning off its GPS in the middle of the ocean. Or, maybe looking at a small town in Texas that suddenly finds its local water table entirely stressed out, all because of a computer.
Yeah, those are the actual indicators.
Okay, let's unpack this. Welcome to the deep dive. Looking at our stack of research today, we are pulling from a really fascinating mix of intelligence.
We really are. It's quite a stack.
Yeah, we've got maritime shipping data coming out of the UAE, grid investment forecasts from American Electric Power, some G7 policy memos on critical minerals, and economic reports from ASEAN summits.
And, when you lay all these incredibly detailed, seemingly disconnected structural reports out together, a completely different picture of the world emerges.
Exactly. And that's the core mission of our deep dive today. We want to move past that surface-level panic you see in the daily news. We're going to look beneath the noise at the quiet, invisible reorganizations happening all around us.
Right, looking at the actual operating systems running the physical world.
Yeah.
And that is the vital analytical lens we need to apply here. If we want to understand what's really happening beneath the surface, we have to temporarily set aside the traditional nation versus nation framework.
Right, the usual geopolitical map.
Exactly.
Right.
As an analytical tool for understanding global infrastructure, that 20th century way of reading the board is, frankly, increasingly obsolete. Instead, we need to observe the massive reorganization of what we can call the port OS, the power OS, the city OS, and the resource OS.
Okay, I like that framing.
And to really understand how they interact, we have to examine the concept of shear.
Okay, well, I hear you on this systems level approach, but I do have to push back just a little bit on the premise. I mean, tell that to the countries currently fighting over borders, right? How can you say the nation versus nation lens is obsolete when actual physical conflicts are actively dominating the headlines right now?
No, it's a completely fair challenge. The conflicts are undeniably real, obviously, but they are the surface symptoms of deeper structural fractures.
Yeah, okay.
Geopolitics is still happening, but the underlying mechanisms driving the leverage, the power, the money, the logistics, all of that has migrated into these vast overlapping operating systems.
So the infrastructure is driving the conflict, not just the borders.
Exactly. The traditional borders matter less than the network connections.
Yay.
And that brings us to shear.
Right.
So in engineering, structural shear happens when two connected parts of a structure are pushed in opposite parallel directions.
Yeah.
In the context of our sources today, it's a velocity mismatch.
A velocity mismatch.
Yeah. It is the intense friction generated between the fast OS, which is artificial intelligence, global finance, digital markets that basically move at the speed of light, and the slow OS.
The physical world.
Right. The highly physical, sluggish world of concrete, copper wires, maritime logistics, and human living systems.
So our central thesis for you today is basically this. The world may not be collapsing. It may simply be becoming harder to read.
That's a great way to put it.
We are feeling the intense friction of trying to run lightning-fast 21st century software on heavy, physical 20th century hardware. And to really see this sheer in action, we kind of have to start with the most foundational slow system we have, which is the physical movement of global goods.
The port OS.
Right. Let's look at what the maritime data is actually telling us about the Strait of Hormuz.
Yeah, because when we look at the Middle East through the traditional news lens, we just see conflict, and we instinctively assume the regional logistic systems are just going to halt.
Like a complete hard stop.
Exactly, a hard stop.
Mm-hmm.
But the shipping data shows something far more nuanced and, honestly, in many ways, more complex to manage. The Strait of Hormuz isn't fully shut down.
Right, ships are still moving.
They are. Instead, what we're seeing in the UAE reports is a massive boom on their east coast. Ports like Fujairah and Khor Fakkan are experiencing explosive, almost unmanageable growth as bypass roads. They're being rapidly forced to become the new vital nodes of the global port OS.
Right, because everyone is desperately trying to avoid the strait, but the ships that absolutely have to go through are still going through. It's not a concrete wall.
Exactly. They are passing through, but the entire system has shifted into a state of what the analysts call probabilistic logistics.
Probabilistic logistics. I actually love that term.
It's very descriptive, isn't it?
It is, because it sounds like a highly academic way of admitting, well, we genuinely have no idea when this boat is going to show up.
That is essentially exactly what it means. It is a fundamental breakdown of certainty. A cargo ship can still get through the strait, but suddenly its arrival time at its destination is entirely unpredictable.
Because of delays, rerouting.
Insurance rates, too. They are fluctuating wildly from day to day, which can actually change the economic viability of a voyage mid-transit.
That's insane.
And the automatic identification systems, the AIS tracking beacons that global supply chains completely rely on to know exactly where a shipment is at any given second, those are being routinely turned off or digitally spoofed to avoid targeting.
Right, the dark ships we mentioned earlier.
Right, so the foundational certainty that modern global trade was literally built on is simply gone.
It really makes me think of a buffering internet connection.
Oh, how so?
Well, if I'm downloading a file, I know the data is eventually going to arrive, but the mere unpredictability of when it gets there completely ruins the efficiency of the entire system relying on it.
That's a really good analogy.
Like, if a video call drops out for 5 seconds every 2 minutes, the connection isn't permanently severed, but the system is essentially broken for my purposes.
Right, you can't have a real conversation.
Exactly. And if I'm a factory manager and I don't know if my crucial components are arriving on Tuesday or next month, I can't run my business.
That analogy perfectly captures the mechanism of the friction here. The real danger to a modern, just-in-time global supply chain isn't a hard stop.
Because you could just plan around a hard stop.
Exactly. A hard stop can be planned around. You find a new supplier, you reroute entirely, you write off the loss. The real danger is the slow, grinding degradation of reliability.
The unpredictability.
Right, because global finance and commodity markets, the fast OS, they demand absolute precision to maintain their profit margin.
Yeah.
So when the physical ships, the slow OS, become unpredictable, that velocity mismatch creates massive friction in the system.
And here's where it gets really interesting to me, because that friction generates heat, invisible economic heat.
Yes.
And I was reading through the pricing reports in our stack, trying to figure out where that heat actually goes, because it doesn't just evaporate, right?
No, it certainly doesn't. It transfers quietly down the line. It cascades through the supply chain until it hits the end user.
So us.
It shows up in the slow creep of rising electricity prices.
Right.
Because fuel delivery was delayed somewhere. It shows up in communication infrastructure costs. And, in the price of food at your local grocery store.
Right.
The global market hasn't collapsed. It has just silently transferred the immense cost of that logistical friction directly onto you, the listener.
Wow. So the physical cargo is hitting this intense friction, forcing the Port OS to completely reorganize on the fly. But the sources show we are seeing the exact same dynamic happen with digital cargo.
The data itself.
The data itself. Artificial intelligence is slamming into some incredibly harsh physical realities, and it is actively forcing cities to fundamentally restructure themselves.
It really is. For a long time, I think the public has thought of AI as pure software, just, a magical entity floating in the cloud.
Right, exactly.
But the cloud is, in reality, a massive warehouse full of highly specialized computers.
Yeah.
And those computers are extremely thirsty and hungry for physical resources. AI is no longer a software industry. It has forcefully morphed into a heavy infrastructure system.
Yeah.
It is a superpower, super cooling, and super resource industry.
The numbers in the investment forecasts are just staggering. I mean, there's this deal detailed in the notes with the company called Hut 8 down in Nueces County, Texas.
Yes, that's a massive project.
We're talking about a nearly $9.8 billion AI data center agreement. They are starting the facility at 352 megawatts of power and scaling up to a 1 gigawatt class facility.
It is astronomical.
A gigawatt, that's the power consumption of a major city.
Yeah.
Just for this one center. And to support this kind of unprecedented draw, American Electric Power AEP is boosting its power grid investment plans to $78 billion.
And those figures represent a seismic capital shift. It is the fast OS, which is, scaling exponentially, turning around and demanding that the slow OS of concrete, transformers, and high-voltage copper wires catch up immediately.
Right.
But the physical grid takes years to upgrade. You have land rights, heavy manufacturing, municipal approvals. AI development operates in weeks and months.
That's sheer again.
Exactly. And this velocity mismatch is completely changing how we evaluate the city OS itself. Historically, the success or potential of a city was judged by its population growth, its commercial real estate market, or, its cultural cachet.
So my deduction here is that the real constraint on AI isn't the code anymore. It's literally finding a municipality that can plug the servers in without blacking out a residential neighborhood.
You have hit on the exact bottleneck. The new criteria for a successful city OS are fundamentally shifting away from human-centric metrics.
Wow.
Cities of the future, and increasingly the present, are being judged by institutional investors based on their power and water surplus. What is the base load capacity of their electrical grid? How fast can they build new substations? And critically, what is their municipal cooling capacity?
Let's break down the mechanism of that cooling capacity, actually, because I want to make sure the physical reality of this is clear.
Yeah, please.
When you or I pull out our phones and ask an AI a complex question or, ask it to generate an image, we aren't just pinging an abstract digital void.
No, not at all.
We are literally initiating a physical process that pulls cooling water out of a local river somewhere, runs it through a massive heat exchange system, and puts immense stress on a local power plant.
That's right. Every single digital query requires physical computation. And that computation generates intense thermal output. If you pack tens of thousands of these advanced processors into a single building, the heat generated is enough to literally melt the hardware if it isn't constantly mitigated.
Which required water.
Immense, continuous flows of local water to cool the systems, and massive amounts of electricity to run the chillers and pumps. I saw you looking at the case studies from Japan in our research stack.
Yes. The Japan reports were wild. I mean, they are already experiencing intense local conflicts where rapid AI infrastructure development is directly competing with local agricultural and residential communities for water access.
It's a zero-sum game in some of these places.
It's literally a neighborhood versus a server farm. The AI facilities need the exact same municipal water table and the exact same local power substations that the hospitals and schools rely on.
And this is the visceral reality of sheer. The digital world is theoretically infinitely scalable. The physical world of water tables and copper mines is emphatically not.
Which naturally brings us to the actual physical materials, because if we need to build this entirely new $78 billion power grid to support these AI data centers, we need the raw stuff to build it out of.
Exactly.
And our policy memos show that the way the world views these materials is quietly but radically shifting. We aren't talking about simple commodities anymore.
No, we are observing a complete reclassification of critical minerals at the highest levels of governance.
The G7 memo.
Right. The G7 recently moved to create a permanent management structure specifically for rare earths and critical minerals. They are officially recognizing that you cannot run, let alone defend, a 21st century civilization without unrestricted access to these specific elements.
And it's not just the G7 reacting, right? It's the countries sitting on the reserves making massive structural plays.
Lovely. Look at Argentina.
Right. The reports outline their massive accelerated plan to expand lithium and copper exports. They are anticipating something to the tune of $32.7 billion in mining exports over the next 10 years.
They know exactly what they hold.
They really do. Lithium, copper, rare earths, they are the foundational wiring material for multiple overlapping operating systems. The electric vehicle OS requires them. The AI data center OS requires them. Advanced military systems, the entire semiconductor supply chain, they all fundamentally rely on the exact same physical rocks.
Absolutely.
I want to try an analogy here, actually, to see if I'm tracking the shift in value.
Go for it.
Imagine a country sitting on a massive, endless forest of premium timber.
Right.
100 years ago, simply having the forest made you powerful.
True.
But today, if you have all that wood, but you have no sawmills, no heavy-duty roads to transport the lumber, and no workforce to process it, the raw wood is practically useless on the global stage.
It's stranded potential.
Right, so it seems like it's not just about digging the rock out of the ground anymore. I'm assuming the real bottleneck is just getting enough ships to move it out of Argentina.
Well, you would think the transportation is the primary hurdle, but the logistics are actually secondary in this specific context.
Oh, really?
Yeah. The real stubborn constraint is the refining process. Taking raw lithium ore and refining it into battery-grade material is an incredibly energy-intensive and chemically complex process.
So it takes power.
Massive amounts of power and immense volumes of water. You literally cannot refine critical minerals without a robust, highly developed power OS and water OS right next to the mine.
Wow, so the bottleneck isn't the rock, the bottleneck is the infrastructure required to make the rock usable.
Precisely. And this fundamentally alters global leverage. For the last century, the central geopolitical question was simply who owns the resource.
Right, like oil.
Exactly. Ownership of an oil field dictated your power. But today, with critical minerals, the central question has shifted to whose OS does this resource sync with?
Whose OS does it sync with? Meaning, like, can you actually plug Argentina's raw lithium into the global semiconductor grid without the system crashing?
System compatibility is everything now. Argentina might have the lithium deposits, but does their local power grid and their port infrastructure sync smoothly with the fast OS of global battery manufacturing?
Right.
If there is too much friction, too much structural shear in their local systems, the resource stays in the ground. Or it is bypassed entirely for a competitor whose systems integrate more cleanly with the global network. It is a highly complex web of dependencies.
Okay, so let's trace this friction because it's moving. We've watched it ripple out from the probabilistic logistics of global shipping lanes in the Middle East. We've seen it hit the power grids of cities in Texas and Japan, and we've tracked it down into the copper and lithium refining constraints in South America.
It's everywhere.
It is. But where does all this systemic pressure actually pool? According to our economic reports, the place where all this invisible heat is accumulating is global manufacturing, specifically in Southeast Asia.
Yeah, we have to look closely at ASEAN, the Association of Southeast Asian Nations. If you read the transcripts from the recent economic summits, the central defining issue overshadowing almost everything else has quietly become the energy and infrastructure crisis.
But logically, Southeast Asia isn't directly involved in the shipping disruptions in the Strait of Hormuz.
No.
And they aren't the ones fighting over water with AI data centers in Texas. So how is this their crisis?
They are deeply connected through a mechanism our sources refer to as remote membrane pressure.
Remote membrane pressure. It's a great phrase, but what is the actual mechanism there? Like, how does a ship turning off its GPS in the UAE explicitly inflate the margins of an auto parts manufacturer in Vietnam?
Let's break down the mechanism. Imagine the global economy is a series of connected fluid-filled membranes.
Okay.
When you apply intense pressure to one side, the fluid transfers that force, stretching the membrane on the complete opposite side of the system.
Ah, I see.
So the instability in the Middle East, that probabilistic logistics we discussed, causes immediate spikes in maritime insurance and fuel hedging. And the shipping companies, they pass those massive costs on to the manufacturers.
Okay, so the cost of getting the raw materials into the factory skyrockets.
Not just the cost, but the timing. Southeast Asia's manufacturing base, specifically in automotive parts, and the highly sensitive back-end processing for semiconductors, well, it relies on microscopic margins and precise just-in-time delivery.
Right, there's no room for error.
None. When the port OS gets jittery, a factory in Malaysia might have to halt its semiconductor packaging line for 3 days waiting for a delayed component.
And that costs money.
Exactly.
Yeah.
To make up the lost time and meet their contracts, they have to run their machines at maximum capacity, paying premium surge pricing for local electricity, which then strains their local power OS.
Oh, wow.
The manufacturing OS of ASEAN relies on precise inputs. When those inputs become unpredictable, the entire manufacturing system starts to physically overheat.
My major deduction here, though, is about the financial markets.
Okay. If this pressure is building up so heavily in Southeast Asia, and it's actively threatening the semiconductor and auto supply chains,
Yeah.
why is this considered silent? I mean, why haven't the financial markets, the ultimate fast OS, reacted to this yet? Wall Street should be flashing red.
The financial markets miss this because they are inherently designed to measure the surface narrative.
Right.
They track daily stock prices, quarterly earnings reports, formalized contracts. They are not built to measure the deep structural shear of physical infrastructure. Our sources refer to this phenomenon as silent heat accumulation.
Silent heat accumulation. So it's kind of like a hairline fracture developing deep inside the concrete pillar of a bridge.
Yeah.
The cars keep driving over it. The traffic helicopters report that the commute is flowing perfectly. Everything looks completely normal up until the day the structural integrity gives out.
That is exactly the dynamic. The structural pressure is spreading quietly. It's pooling in the manufacturing centers of Southeast Asia. The local energy costs are rising. The profit margins are shrinking. The municipal grids are straining. But because it hasn't snapped yet.
Right, because a major multinational factory hasn't literally declared bankruptcy and shut its doors yet, the global financial algorithms just haven't recognized the shift, the reorganization, the degradation. It's happening entirely beneath their radar.
It is genuinely wild to start looking at the world this way, to stop looking at borders drawn on a map and start looking at these overlapping systems of power substations, municipal water pipes, data fiber, and shipping lanes.
It requires a profound and sometimes uncomfortable shift in perspective. But once you start looking at the world as a series of interacting operating systems struggling to synchronize, well, the chaos you see on the evening news starts to make a strange structural sort of sense.
It really does. So let's bring this all together. What is the takeaway from this massive stack of intelligence? The traditional dials are spinning wildly, and if you only look at the surface level events, you'd probably be forgiven for thinking we are on the brink of total collapse. But the data tells a different story.
Right. The physical world is still turning. What we are witnessing is not the breaking of the world, but a massive, silent, and incredibly stressful reorganization.
A reorganization.
Yes, we are watching the city OS, the power grids, the water tables, and the AI connectivity networks desperately trying to sync up with each other in real time.
It is the intense friction of trying to run that 21st century fast OS of artificial intelligence and high-speed financial markets on the heavy, physical 20th century slow OS of ports and power grids.
Exactly.
So the world isn't collapsing, it's just upgrading, and the upgrade process is generating a massive amount of invisible heat.
Navigating that heat is going to be the defining challenge of the next decade. But, recognizing that this is a structural upgrade, a reorganization of resources, rather than an apocalyptic collapse, it provides a much more grounded way to approach the future.
Right, it's observable.
It is. It allows us to observe these massive systemic changes calmly, tracing the cause and effect, rather than just reacting to the news cycle with panic.
It takes the fear out of the equation and replaces it with clear-eyed observation. Which actually brings me to a final thought I want to leave you with today. Something for you to mull over long after you finish listening to this deep dive.
Sure.
We talked about how the fundamental criteria for a successful city are rapidly changing. How municipalities are no longer being evaluated on their culture or livability, but on their power grids, their cooling water availability, and their fiber optic capacity so they can attract and run massive AI data centers.
Right.
If the cities of the near future are being evaluated primarily on their physical capacity to run artificial intelligence, what does that mean for the human slow OS that still has to live in them?
Yeah.
Are urban environments being quietly redesigned to optimize the lives of servers rather than the lives of citizens?
It's a profound question.
Next time you walk around your own hometown, look up at the high voltage power lines. Look at the water infrastructure projects. Look at the massive new windowless developments on the edge of town. Try to spot the invisible reorganizations happening right in front of you. Try to read the new dashboard. Thanks for joining us on this deep dive. We'll catch you next time.